Okay, in this segment, I want to talk about solids. Now, if you have taken any advanced courses, you know that a solid is generated from a two-dimensional object that's revolved around a third axis, that third axis being the z-axis. Fortunately, they don't ask you any problems where you have to know how these shapes are generated. You don't have to deal with 3 dimensions. Everything's going to be in 2 dimensions, and that'll be a 2-dimensional coordinate system that you'll be dealing with. And all the problems, most of them will boil down to dealing with just slices of these 3-dimensional objects. And if you slice them, sometimes you're going to end up with, let's say you're slicing a cone, you could end up with a parabola, or you could slice it and end up with a triangle, and you'll be dealing with those 2-dimensional shapes. Let's take a look now at, and by the way, you're not going to have many of these solid type equations on the test, and if there's any formulas to be known, they will be given in the math section itself. So let's take a look at a problem and see how we would solve it. Okay, let's take a look at this problem now. We have a cone. Let's read the problem together. A right circular cone is drawn above with 2 circles centered at A on its base as shown. AB is the height of the cone. The measure of angle ABC is 60 degrees. And BC has a length of Y. If BD bisects ABC, which of the following gives the area of the smaller circle in terms of Y? So what is it we have to find? We have to find the area of this circle down here. Let's just first start out by seeing what's required when you do area of a circle. And you probably have this memorized by now. And if you don't, of course, the area of a circle is over here, that you can look at it anytime you want. So how are we going to do that? Well, we have to look at the information they've given us. Let's look at that. They say this angle ABC, and the B means that's the vertex, is 60 degrees. So we know this angle up here has to be 60 degrees in this big triangle ABC. And if that's 60 degrees, we know this one down here has to be 30, because 30 plus 60 plus 90 equals 180, and every triangle has 180 degrees. Now another bell should be going off in your head, especially if you have already gone through the segment where we talked about triangles, because this is a special triangle called a 30, 60, 90 degree triangle. Let's look at the relationship. We'll look again at our cheat sheet. You'll notice that on a 30, 60 degree triangle, we have some definite proportions. That the side opposite the 30 degrees, which you call x here, is exactly 1/2 of the hypotenuse. Or saying that the other way, the hypotenuse is exactly twice that side opposite the 30 degrees. And the side that's opposite the 60 degrees is the side opposite the 30 degrees times the square root of 3. So let's go back now and use this information, if we can, in our problem. So let's first look at what it means here. They told us that this side here is y. The hypotenuse is y. So if the hypotenuse is y, as I said a minute ago, the side opposite the 30 degrees, which was this side here, AB, has to be 1/2 of that. So we know this is y over 2. And let's also look at the fact that they've told us something else here. They've said this dotted line here is bisecting this angle, ABC. And when it bisects means cut in half. So both of these triangles, triangle BDC and triangle ABD, all have 30 degrees up here in the top. We are concerned about this triangle here because it includes the radius that we need for our formula over here. So let me just crudely draw that triangle here so we can kind of keep track of what we're doing. And I'm going to label it A, D, and B. And like I say, they bisected the angle, so we know this is 30, which means this one down here has to be 60. So we have a 30-60 degree triangle. Now let's look at the relationships. We also know that that side over here is y over 2. Well, that's the side opposite the 60 degree angle. Let's look again. The side opposite the 60 degree angle, in order to use these ratios, is something multiplied times the square root of 3. Well, the problem is we don't really have it in that form right here. We have y over 2. That doesn't look like something times the square root of 3. So I'm going to make it something times the square root of 3. It's a little device. As you know, you can multiply anything by 1 and it doesn't change the value. But my 1 is actually just going to be the square root of 3 over the square root of 3. Now when we write it this way, it makes more sense because then we know that this side over here is going to be this. And we also know that the factor that was multiplied times it, which is our distance AD, has to be this part right here, since that's the square root of 3. So we now know that AD equals y over 2 times the square root of 3. That's this part right here. So that's also the radius r in our area formula. So we're going to now go over here to our formula and plug that in. A equals pi times y over 2 times the square root of 3. We're going to square that. And let's bring it down. A equals pi times y squared. And 2 times 2 is 4. And the square root of 3 times the square root of 3 is 3. And so we end up with pi over 12 times y squared. Come over here and we look for one of the answers that looks like that, and we see that it is E.